Light and color theory in 3D movements. How light affects 3D objects. Shadows. Lights create a shadow which help define the shape and depth of object. Shadow change as the light source or object moves. Highlights and reflection. Light creates highlight on shiny surfaces and reflection on mirrors or water. These effects enhance the realism of 3D models. Number two, we have color theory. Color component, we have view the color itself, red, blue, green. Saturation, the intensity or purity of the color. Brightness, the lightness or darkness of the color. How color theory applies. Texture mapping. Colors are applied to 3D models using texture, which are images wrapped around the objects. These textures define how the surface looks under different lighting conditions. Material properties. Material define how surface interact with light. For example, a shiny material reflects light different than a matte one. Number 3. Light and color 3D in 3D movements. Animating light. Moving light sources. When a light source moves, it changes the shadow and light highlights on objects, affecting how they look in different positions. Dynamic lighting. Light can change over time, such as sunset transitioning from bright daylight to dim twilight. Color and movement. Color shifts as objects move. Their color might appear to change based on lighting condition or the angle of view. This is due to change in how light interacts with the surface. Mood and atmosphere. Changing the color and intensity of lighting can set different moods. For example, a blue light might create a cool nighttime feel, while a warm yellow light creates a cozy daytime atmosphere. Shading model for realistic texture and shadows. Number 1. Basic shading modeling models. Flat shading. What it is the simplest shading model. Each polygon on 3D objects is a given single color. How it looks results in a faceted blocky appearance because there's no smooth transition between colors and across polygons. Use. Often used in low detail models or wireframes. Go road shading. What it is smooth out the shading across the surface by interpolating vertex colors. How it looks. Create a smooth gradient between polygons, reducing the blocky appearance of flat shading. What is use? Good for moderate realism where smooth transition are needed but with less computational cost. Foam shading. What it is? A more advanced model that interpolates normal surface direction across polygon and calculates color at each pixel. It looks provide a smooth, shiny appearance with more realistic highlights and shading. Commonly used for objects where high realism is required, such as shiny surfaces or detailed texture. Number 2. Advanced shading models blend foam shading. Or it is a variant of foam shading that improves how highlights are rendered. It looks better at simulating shiny surfaces with softer and more realistic specular highlights. But use is for frequently used in modern graphics for realistic materials and surfaces. Physically based rendering or PBR. What is a comprehensive model that simulates real-world lighting interaction using principles from physics. How it looks provides a highly realistic results with accurate reflection, texture and materials. Takes into account properties like roughness and metalness. Widely used in modern games, simulation for high realism. Texture mapping. Texture mapping, so it is applying images texture to 3D models to give them detailed appearance, how it looks. Texture add details like color patterns and surfaces irregularities, combined with shading models texture enhance realism. Used for essential creating realistic surfaces such as wood grain, skin or fabric. Number 4, we have shadow mapping. What it is a technique where shadows are projected based on the light source view. Now, how it looks. Creates a shadow by comparing the distance from the light source to the object and the depth in the shadow map. Commonly used in real-time graphics to simulate shadows in dynamic scenes. Ray tracing. What it is? A technique that traces rays of light as they interact with objects to create accurate shadows and reflections. How it looks. Produces highly realistic shadow and reflections, including effects like soft shadows and caustics. Used in high quality rendering and visual effects for movies and simulations. Lighting technique. Point, spotlight, etc. Description. A point light emits lights equally in all directions from single point like a light bulb. Effects. Create a soft radial fall off, meaning the light intensity decreases with distance from the source. This type of light casts soft, realistic shadow and highlights on object. Uses for good simulating lamps, candles, or any small localized light source. Directional light. Description. A directional light emits parallel rays in a single direction. Similar to sunlight, it doesn't have a specific point of origin and illuminates all objects equally regardless of their distance from the light source. Effects. Create strong, consistent lightning and shadow, mimicking outdoor lighting conditions like sunlight. Uses ideal for outdoor scenes or any situation where uniform lighting is needed. Number 3, spotlight. Description: a spotlight emits lights in a cone shape, focusing light in the specific direction with defined beam angle. The intensity of the light falls up toward the edges of the cone. Effects. Create dramatic lighting with focus, intense illumination in the center, and softer edges. Spotlights also cast well-defined shadow within their beam. Uses. Useful for simulating stage lights, flashlight, or any scenario where a focused beam light is needed. Area light. Description: an area light emits light from a defined area, like a rectangle or circle, rather than a single point. The light spreads out from the surface, providing soft, diffuse lighting.